This video derives the relationship between macroscopic pressure and microscopic particle collision speed. The pressure, P0, caused by a particle with mass, ma, moving at a collision speed, VCA² in a volume, Va, can be expressed as P0 multiplied by Va equals 1/3 of ma times VCA². This video will derive the relationship between macroscopic pressure, P0, and microscopic collision speed, VCA, based on the kinetic theory of gases. The volume, Va, can be expressed in terms of the radius, Ra, as Va equals 4/3 pi Ra cubed. The total surface area, Sa, of the sphere can also be expressed in terms of the radius, Ra, as 4 pi Ra squared. The time interval delta t between two collisions with the wall is 2 Ra divided by the collision speed, Vca. According to Newton's law of motion, the force, Fa, is equal to the change in momentum divided by the time interval, delta t, between collisions. It is the time for a particle to travel from one side of the wall to the other side of the wall and is equal to 2 Ra divided by Vca. The momentum changes from ma times Vca to negative ma times Vca. This results in a change of momentum of 2 ma times Vca. Rearrange the equation to get Fa equals ma times Vca² divided by Ra. The pressure, P0, on the surface of the sphere is the force, Fa, divided by the total surface area, Sa, of the sphere. Using the previously derived formula, we can express the force, Fa, in terms of ma, Vca, and Ra. Similarly, using the previously derived formula, Sa equals 4 pi Ra square, we can express the surface area, Sa, in terms of Ra. Rearranging the equation gives P0 equals 1/3 ma divided by Va times Vca², which is the relationship between pressure P0 and collision speed Vca. In summary, the relationship between pressure P0 and collision speed Vca can be obtained by expressing 1. Delta t, surface Sa, and volume Va in terms of collision velocity Vca and radius Ra, 2. Force in terms of mass ma, velocity Vca, and radius Ra, and 3. P0 in terms of mass ma, volume Va, and collision velocity Vca. Thank you for watching.